So some of you may have noticed that when we use dynamic memory allocation in classes, we will have allocated a dynamic array, let's say, in our previous example, but we don't have a matching delete. So remember, a long while ago, I said that whenever you see a new, you want to look somewhere, not necessarily in the same function, but somewhere for a matching delete. And it turns out what you need for this is a destructor, where you delete this dynamically allocated variable x, data member x. So far we haven't had to use the destructor because when we set up things on the stack, x, let's in this case x, y, and z are all allocated on the stack. When you exit the scope that it's declared in, so in this case it's main, when you exit main, in this case all of these variables are freed. The memory for all of this is freed. And it turns out this is okay for this particular case. But if you had, let's say, some function somewhere out there, let's say we do all of this function somewhere deep inside some other object and some that's also called, let's say, from indirectly from main, then when you allocate x, y, and z, you're allocating memory from the heap using new. And so if you exit this function, whatever this is, let's say it's not main, something somewhere else, that these x, y, and z objects are deallocated, but that doesn't mean that this memory allocated using new is deallocated. It's actually not. So it's just sitting there allocated. If you if you create a few million of these ABC objects, you will have, and you don't delete any, if you don't deallocate memory that you allocate using new, all this memory just sits there, clogs up your system. Your programs will start to slow down, and your memory usage will go up. Eventually the program will crash. So you don't want that to happen. So how do you fix this? You say that you want a destructor. And this destructor actually does get called. We get a default destructor just like you get a default constructor and a default copy constructor. And so what happens is, at the end of this, you actually, even though it's not shown here, you actually call the destructor. So you have something like this, ABC, although you cannot do this, or maybe you can. Normally no one does this. So it's like you have this. You call the constructor, you call the destructor for ABC, and you do it for both x, for all three, for x, y, and z. So let's see, how would you do that? I don't think you can ever do this. So the closest thing would be like x dot destructor. And since we don't do this, I can't even think of what the syntax for this would be. Let's see if this will work. Shouldn't work. I would expect it not to work, but it does. Yeah. So you're not supposed to call the destructor explicitly. What you're supposed to do is, if you have x, y, and z and their pointers, you would say x. You would say delete x. That's it. That is, if you use new. In this case, we're not using new. They're called implicitly, and this is the kind of thing that gets called. If you actually run this, I think you will have problems. Or maybe not. Alright, so it looks like it works, but this is the kind of thing you're not supposed to do because it's done implicitly, and you'll end up trying to delete x twice. In this particular case, I didn't see any problem, but I think when it says terminated here, it actually did run into a problem. If you ran this at the command line, I think you would see the error message. So although the destructor is called, you should not call it explicitly. It's done implicitly for you. Okay, and just to show you that this destructor is called, let's set it up, and we'll just put a print statement to check and make sure. If you have an ABC class, the destructor looks like this. We say tilde and ABC, no parameters in this case. And then let's just put a cout to show that destructor was called. Okay. Okay, so we're not really using the destructor except to show that it is getting called even though it's not, we're not calling it explicitly. Let's check this out. Let's build this. It compiled, it should compile. And notice, even though I don't call the destructor, you get this printed out 3 times, once for each of these things. Okay? Alright, so this is just to show you that it is getting called. Now what exactly do you do in a destructor? Remember that every time you see a new, you want to have a matching delete. So you want to match that new. So how do you do that? You just say delete. And remember, for an array, you have to use open close square bracket to indicate that it's an array. And you say x. You don't have to say anything about how big x is. The system actually keeps track. If you use this open close square bracket, it will delete the entire array. The system knows from this new that it allocated 5 locations, 5 ints. And what you will see in this case is that everything will work. In this case, nothing is different really. You just get this print statement because we just get this output because we have the cout statement saying print out that the destructor was called. Okay, this is the kind of thing you want to have. If you have, in general, if you are going to use dynamic memory, you absolutely have to have destructors. Some of you may have seen that when you use the wizard in Eclipse, you get a virtual. We'll go over that later. Virtual comes in only when you have inheritance. In this case, we have no inheritance, and so this doesn't matter whether you have virtual or not. It doesn't make a difference. When you have inheritance, then you want all your destructors to be virtual. Okay, in this case, it makes no difference. It compiles and runs just like before. Okay, so let's try to finish up this chapter. We need a destructor whenever we have dynamically allocated variables. They don't just go away unless they're deleted preferably in the destructor. If pointers are only private member data, then they allocate real data usually in the constructor, and you must have the means to deallocate them when the object is destroyed, and the way to do that is the destructor. This is the opposite of the constructor. It's automatically called, as we saw. We put in couts, and we saw that those things get printed out when the object goes out of scope. The default version, and you do get a default destructor, only removes ordinary variables and not dynamic variables. So I can't stress this enough. If we did not have a dynamically allocated variable, you just had a static variable array of size 5, you just had int x open close square bracket 5, destructor actually takes care, the default destructor does the right thing and takes care of deleting all this stuff. It's only when you use new dynamic memory allocation that you need to use destructors. Okay, and this is how this works. If you inline it, you just say tilde, your class name, open close parentheses, and perform all the delete cleanup duties. The one last thing that I want to go over is copy constructors. We actually did do this a long time ago. Copy constructors are usually, you get a default copy constructor which does the right thing. The point at which you have to worry about whether you need to define your own copy constructor is when you use dynamic memory allocation. And this is automatically called, you get a default one whenever a class object or an object is declared and initialized using some other object. It's automatically called. So even if you don't have one, if you have something like this, right, you can do this. Right, this is allowed. Let's just check, compile, and run. Yeah, all of this works. Oops. Error for object pointer being freed. Oh yeah. So in this case, yeah, good point. This copy constructor is there, but it did the wrong thing. Here's a perfect example of when you call the destructor for y, it actually, by that time it had already called the destructor for z. It happens in opposite order. So when you declare x, y, z, you call the destructor for z first, and then when you call the destructor for z, what happened was we destroyed this array. We take that back. We deleted, or we deallocated this array x. Then what happens is we try to we call the destructor for y, and when we do that, we ran into a problem. That is, it tried to deallocate this array x, but because we used the copy constructor, what we had done was we ended up using the default behavior of the copy constructor, which was to just copy this value x from y into z. And that's the wrong thing. That's why, remember, that's the problem we ran into with assignment. And so now what we need is a copy constructor to do the right thing. How do we do that? Here's what it looks like. ABC reference, that's a return type. I'm sorry, ABC, and then we just say what is the thing that we're that we're copying from, and we make that a const. ABC, and we'll call it source. And that is our default copy constructor. And let's just check and make sure that we are actually calling the copy constructor. Let's print out something. Now normally I would say do not do this kind of thing. Do not have couts in any member functions anywhere, if at all possible. Do not have couts. This is okay just because we are just looking at how things like copy constructors work. All right. Okay, so this is giving us a warning saying we're not actually doing what we're supposed to do, that is copying stuff over. Okay, so this is just here to, this is actually still not going to do exactly what we want it to do, but that's okay. Compile it and run it, and notice here we call the copy constructor. Even though we don't actually call it explicitly, this is actually, I guess this is in sort of an explicit call to the copy constructor. Okay, so now we are calling the copy constructor. We no longer get that error, but that's only because we're not actually doing anything in the copy constructor. What we should do is the same kind of thing we did for the assignment operator. But before we do that, x is actually undefined, so we actually have to do the same things we do in the normal constructor. Copy that, allocate memory. All right, there we go. So here's what our copy constructor looks like. We have a data member. We have to initialize all the data members. If it's a dynamically allocated array, we have to actually allocate the array in our copy constructor. Then we take the source, and look at the X data member in there, copy each of those elements over to our destination, which is this. And we do this final print cout. Remember, do not do this. This is only for testing. And once you test it and make sure everything is working, remove all these couts. It's just this, you don't want to have that in your code. It's just bad form. Okay, so now everything works. Okay, we actually do call the copy constructor. When we do this, we actually make a complete copy of y in z. Initially, z has the value 2. We do the assignment, and even though that's not obvious, we actually do call the destructor implicitly. Okay.